Hello, good afternoon to all of you. I hope all of you are doing well. In today's class, we are going to discuss instruction and instruction set classification. Now, an instruction is a binary pattern that is designed inside a microprocessor that is capable of performing specific function. Now, the entire group of instruction is called as an instruction set. So with each and every microprocessor, there is a set of well-defined instruction that determines the capability of the microprocessor. Now, the instructions that are supported by the microprocessor can be classified into functional categories. The functional categories are number one, we have data transfer instruction, we have arithmetic or data transfer operation, we have arithmetic operation, we have logical operation, we have branching operation, and we have machine control operation. So any of the instructions that are defined for a microprocessor, can be categorized into either of these five categories. So let us begin with the first one, that is data transfer operation. Now, the instructions that are defined within this category are capable of copying data from the location called as source to the location called as destination without altering the content of the source. Now, at times it may be confusing here. Data transfer basically implies copy function. So you need to remember that here data transfer basically implies copy function. That is, it does not destroy the content of the source. Now, the various types of data transfer that may be possible are data transfer may be possible between two registers. Yes, data transfer can be made from register B to register C. Likewise, specific data byte to a register or a memory location, like load B with the data byte 32H example. Now third one, between memory location and a register, right? So an example, from a memory location to a register, from a memory location 2000H to register B, right? And between IO device and the accumulator, so for an example, from a keyboard to the accumulator. Now these are the various instances in which the instructions can be used for copying data. Now, the next category of instructions that we have is called as the instructions that are capable of performing arithmetic operation. Now, arithmetic operation that includes addition, subtraction, increment, and decrement, right? Now, let's start with addition. Now, any 8-bit number or content of the register or content of a memory location can be added to the content of the accumulator. Again, I'll repeat it. Any 8-bit data or content of the register or content of the memory location can be added to the content of the accumulator, and the result is stored in the accumulator. So this is very much important for us to know that addition, in case of addition operation, the result is always stored in the accumulator. Now, no two 8-bit registers can be directly added to each other, so we cannot add register B and register C, right? But there is an exception. There is an instruction that's called as DAD that adds the content of the 16-bit registers, right? So content that adds the content of the register pair. So this is very much important. You need to remember there is an exception DAD that adds the content of the register pair. Now subtraction. Now any 8-bit data or content of the register or content of the memory can be subtracted from the content of the accumulator, and the result is stored in the accumulator. So any 8-bit number or 8-bit or the content of the register or the content of memory location can be subtracted from the content of the accumulator, and the result is stored in the accumulator. Now the subtraction is performed in 2's complement, and if the in situation if the result is negative, then it is expressed in 2's complement. Now, here in situation of addition and subtraction, so if there is a carry in case of addition, and and there is a borrow in case of subtraction, that carry flag is set. Again, I'll repeat it. In case of addition, if there is a carry, and in case of subtraction, if there is a borrow, then carry flag is set. So carry flag is used to represent both the status, that is carry as well as borrow. Now increment. Now increment and decrement. So the 8-bit content of the register or memory can be incremented or decremented by 1. Okay, again I'll repeat it. The 8-bit content of the register or memory can be incremented or decremented by 1. Similarly, 16-bit content of the register pair, right? Okay, can be incremented or decremented by 1. So, for an example, content of the BC pair can be incremented or decremented by 1. So, you have different instructions. You have INR and INX, okay? The 8-bit increment and 16-bit increment. So, increment and decrement, so the 8-bit content of the register or memory location can be incremented or decremented by 1. Similarly, 16-bit content of the register pair can be incremented or decremented by 1. Now, the increment and the decrement operation differs from the addition and subtraction operation in one important way, that they can be performed in any one of the register or in memory location, right? Okay? So what we have is we can perform increment in a particular register. Whereas in case of addition and subtraction, accumulator has to be one of the default operand. Now, logical operations. So now these instruction performs realization of the logical gates. Like we can have logical gates with the content of the accumulator, right? Okay, with the content of the accumulator. So we have AND, realization of AND, or an exclusive OR gate. So any 8-bit number or content of the register or of memory location can be logically ANDed or ORed or exclusive OR with the content of the accumulator. Again, I'll repeat it. Any 8-bit number or content of the register or content of a memory location can be ANDed or ORed or exclusive OR with the content of the accumulator, and the result is stored in the accumulator. Now rotate. Now each bit in the accumulator can be shifted either left or to the right by the next position. So we can rotate the content of the accumulator as well, right? So we have rotate towards left or rotate towards right. Now compare. Now any 8-bit number or content of the register or memory location can be compared with the content of the accumulator for greater than, equality, or lesser than. Again, I'll repeat it. Any 8-bit number or content of the register or content of the memory location can be compared with the content of the accumulator for greater than or less than or equals to relation. So it basically works with subtraction operation. Now complement, the content of the accumulator can be complemented. That is, all the zeros are replaced by 1 and all the ones are replaced with 0. Now the next set of instruction that we have are categorized into under branching operation. Now the group of instructions are responsible for altering the sequence of program execution conditionally or unconditionally. You see, again I'll repeat it. The group of instructions are responsible for altering the execution sequence of the program conditionally or unconditional. So you have jump, right? Again, so you have conditional jump and you have unconditional jump, right? So conditional jump are important aspects of decision making process in the programming. So there are several instructions that are defined in 8085 microprocessor that works with the value of the various flags. Say for example, jump on carry, jump on no carry, jump on 0, jump on no 0. So these are the set of instructions that works with the various flags in order to make certain decision to whether or not to alter the sequence of execution, right? Now, in addition, we have instruction called a JMP as well. So it's a jump without any condition. So that is called as unconditional jump. So we can have a conditional jump and we can have unconditional jump. Likewise, we have call, we have conditional call, we have unconditional call. So for example, we have a call function CALL that simply transfers the control to the subroutine, whereas we have a function like call on carry, call on 0, so and so forth. So we can have unconditional jump and we can have conditional jump as well, or conditional branching or unconditional branching. Now let us move on to the next set of instructions that are categorized into machine control operations. So the instruction that falls under this category performs functions such as halt, interrupt, or do nothing, right? Now, so the microprocessor operations related to data manipulation can be summarized into 4 functions. So copy, copying of data, arithmetic operation, logical operation, testing a given condition, and altering the program sequence. So till now, what we have learned is we have learned that we have learned what is an instruction. We've learned what is an instruction set. We have learned the various functional categories under which the instructions defined for a microprocessor can be classified. We started with the first category, that was data transfer operation. Then we move on to arithmetic operation. Then we discussed logical operation, and then we went on to branching operation, and eventually we discussed machine control operation. So this is a very important concept that you need to remember, that the various functional categories under which the instructions can be classified. Now let us move on to the next aspect, that is the instruction format. Okay, right. Now instruction format, an instruction, so as we have already discussed, an instruction is a binary pattern designed inside a microprocessor that is capable of performing some specific function, right? Okay, so each instruction has two parts in it, right? That's what one important thing that you need to remember. It has two parts in it. That is, the first one is the task that is to be performed, that is called as operation code, and the second one is the data to be operated on, that is called as operand. Okay, so again I'll repeat it. Each instruction has two parts. The first part pertains to the operation that is to be performed, or the task that is to be performed, that is called as opcode, and the second is the data that is to be operated on, that is called as operand. Now the operand can be specified in various ways. It may include 8-bit data, an internal register, a memory location, or an 8-bit address, or 8-bit or 16-bit address. Now just see, these are different ways in which the operand can be specified. It can be 8-bit data, an internal register, or memory location, or 8-bit or 16-bit address. Now, the 8085 instructions can be classified into three categories accordingly to the word size, right? Now, what we can have is we can have a one word or one byte instruction, right? We can have 2-word or 2-byte instruction. We can have 3-word or a 3-byte instruction. So these are the possible examples of the classification of 8085 instruction accordingly to the word size. So you have 1-word or 1-byte instruction, or 2-word or 2-byte instruction, and 3-word or 3-byte instruction. Now let us discuss one byte instruction. Now, one byte instruction includes the operand and the opcode and the operand in the same byte. Again, I repeat it. One byte instruction includes the opcode and operand in the same byte. Now, operand are internal registers and are coded in the instruction itself. So again, I'll repeat it. One byte instruction includes the opcode and the operand in the same byte, and the operand are internal registers that are coded into the instruction. So for an example, move C comma A. So move C comma A has one opcode, so it's a 1-byte instruction. Add B is a 1-byte instruction. CMA is a 1-byte instruction. So move C comma A moves the content of accumulator to the register C, right? Likewise, add B adds the content of the register B to the accumulator and stores the result in the accumulator. Now CMA complement the bits that are there in the accumulator. Now just see, each of these instructions, they have 1 byte, right, representing both the opcode as well as the operand. So 1-byte instruction, 1-byte instruction includes the opcode and the operand in the same byte. Now likewise, what we have is we have 2-byte instruction. Now in 2-byte instruction, the first byte specifies the opcode and the second byte specifies the operand. Okay, again I repeat it. In case of 2-byte instruction, the first byte specifies the opcode or the operation code, and the second byte specifies the operand. Now for an example here, MVI A comma data, right? Okay, so MVI A has a opcode right? And you have a data following that. So what does it do? It moves 8-bit immediate data to A, right? So it moves 8-bit immediate data to register A, that is the accumulator. So this is a typical example of a 2-byte instruction. So MVI A comma data or MVI B comma data. So it moves 8-bit immediate data to the accumulator or to the specified register. So in 2-byte instruction, the first byte specifies the opcode and the second byte specifies the operand. So source operand is the data byte immediately following the opcode. So this is implied, right? Now 3-byte instruction. So in 3-byte instruction, the first byte specifies the opcode and the following 2 bytes specifies the 16-bit address. Just remember, in case of 3-byte instruction, the first byte specifies the opcode and the following 2 bytes specifies the 16-bit address. Note that the second byte is the lower order address and the third byte is the higher order address. This we have already discussed in the first two initial classes of the laboratory, that the second byte will be the lower order address and the third byte will be the higher order address. So in a 3-byte instruction, the first byte specifies the opcode and the latter 2 bytes specifies the 6-bit address, where the second byte is the lower order address and the third byte is the higher order address. Now for an example, we have jump instruction, we have STA instruction, we have LDA instructions. So there are several instructions that are there that requires 3 bytes. So now here what we have learned is we have learned that what may be the possible types of instructions based on the number of words. Okay. There are 3 types of instructions based on number of words. So 1-byte instruction, 2-byte instruction, and 3-byte instruction. In case of 1-byte instruction, the opcode and the operand is represented in the same byte. In case of 2-word instruction, first byte will be the opcode and the second byte will be the operand. And 3-word instruction, the first byte will be the opcode and the latter 2 bytes will be the address. Okay, so this is very much important. So in today's class, we've learned about what is an instruction. We have learned about instruction set classification, and we have learned about the different instruction formats that may be possibly there. So thank you very much. Have a very good day.